Sathyabama Institute of Science and Technology.
Hi all, myself Dr. Noella, Assistant Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. The topic we are going to discuss about conversion of RE to epsilon NFA. So this comes under Theory of Computation in Kleen's Theorem Part 1. First of all, let us discuss about what is RE. So regular expressions are shortened as RE. It's an algebraic way to describe different languages. So here in theory of computation, we are considering the different languages as regular languages. So we will give the short form as RL. So if E is a regular expression, then we will be having languages L of E, and we will be describing RE and the RL regular languages as recursive functions only. Definitions. So for regular expression, we should know some basics. So it having three different basics and two inductions. So basic one, from one state to another one state, if we are having one input, for example, A is a string. So a single string with length 1, then we can represent it as L of A is equal to A. If we are not having any particular transition is there, but we have to give some transition, we can use the symbol epsilon to give the transition from one state to another one state. If it does not have any transition at all, then we can give null. So that is RE is equal to A if we are having a single transition. If you are not having any transition but we are pulling with an epsilon transition, we can represent this L of E is equal to epsilon, and if we are not having any transition, then we can represent this null. The two more functions we should know. One is union function and the next one is dot function. So union function, or we can call it as plus function. So L of E1 plus E2, that means either E1 or E2. E1 and E2 is nothing but equations. Set of strings we can call it as equations. So here either we can call it as equation 1 or equation 2, or the union of both we can consider. Then L of E1 E2, that means that the dot function mandatory parts E1, E2 are the mandatory parts. Next we can see what is epsilon NFA. Epsilon NFA is a part of finite automata. This epsilon is the symbol we are using to indicate that is epsilon NFA. So if we are not having any transition, we want to pull with some transition, we can use epsilon symbol. Formal definition for epsilon NFA. So we have defined all the different finite automatas using 5 different functions. So first one is Q. Q represents the set of all states. Q0 is the initial state. Sigma is the set of input symbols, for example 0, 1, A, B, etc. Then dou is the transition function. So here in epsilon NFA, the total number of states we can call it as 2Q. Then F is the final state. For the conversion of an RE to epsilon NFA, so we can use the method called Thomson Construction Method. So this is one of the simplest method. So some basics and induction we studied now. So using that, we are converting it in the form of some diagrams. Using that, we can convert the RE to epsilon NFA. So how the construction work? We are breaking down the regular expression into different small parts. Then we will be combining it using some functions which is known as concatenations, union and clean star. 4, we are having the basics as well as the inductions. So for example, if we are having simple A, then the transition will be like this. So from one state to another one state, we are having an string transition, that is A. Next, epsilon. If you are not having any transition but we are pulling with one epsilon transition, then we have to draw the figure like this. Then if you are not at all having any transition, that will be two independent states. We have to represent it like this. So these are the basic fundamental figures. First we should know, then only we can convert an RE to epsilon NFA. So first induction is union induction. So how we can use an union induction? So first we are having one equation. Equation is nothing but set of strings. We are having equation E1, then we are having equation E2. So how we are representing it is using union. Union is nothing but either this or this. So how we can represent? Using one start state, we can transit using epsilon functions. So this will be combined together using another one state with epsilon transition, and this will be conclude together with using another one transition, epsilon transition function with the end state. So in this particular figure, if the question is like E1 plus E2, then we can consider this is the start state and that is the end state for E1 plus E2. So how? For example, a string is coming, either that can go to this path or this path. Which part it is needed? According to string, it will be selected and it will be checking the case. Next one is concatenation. Concatenation, both the cases should be mandatory. So if equation 1 and equation 2 both have to come together. So this is equation number 1. Then equation number 2 have to follow this. So this is equation 2. So how we can connect? Using a simple epsilon transition, we can connect both like this. So this is E1, E2. So E1 will be followed by E1. So first E1, then this equation E2 will be coming. So next one is induction 3, closure. So closure is any number of times this can be occur. So for example, this is the equation. So first thing what you have to do is, you have to connect this state to this state using an epsilon transition. And there will be two different states which will be connected with this one. So consider this is the case. Then we can, for example, E star. Closure means we will be representing using star. So if it is E star, this is a start state. Consider this is a start state. We will be having one epsilon transition, and after that we will be having one end state that is also having an epsilon transition. Then from this state to this state we will be having another one epsilon transition, and from the start state to end state we will be having another one epsilon transition. So this is E star, closure. Now we can discuss two examples. First example is A star plus B star. So it is very simple. We know the Kleene closure method, right? So A star, this represents A star. So for A, Q1 to Q2 we are having A. Then from Q2 to Q1 we should have an epsilon transition. We have to introduce two new states, Q0 and Q3, and there should be one transition from Q0 to Q3, and this have to connect it together. Same way we can write B star for this A star plus B star. So A star this same thing we can draw for B star. Instead of A we have to write B. So instead of A we are writing B, same figure. Then what is the next thing? We have to use plus symbol, right? So plus symbol means union. So we can introduce a new state here. We can join these two, and we can use another one state over there, and we can join these two. So this is the final figure. This will be the start state and this will be the end state. As you know, start state have to indicate using an arrow mark, and end state you have to indicate using double circles. So this join together. So next example, A plus B the whole star B. So how we can do? You know, when we are breaking down A plus B we have to draw first. So A plus B, correct? So A transition, B transition we join together using epsilon transition. Then star, A plus B the whole star. So A plus B, then we have to introduce two new nodes and we have to connect it together. So A plus B the whole star. So from here to here we can check, that is A. So this is A, this is B, this is A plus B, and this whole figure together we can have A plus B the whole star. And finally one mandatory thing is there, that is B. So after completing this figure we can join one B, and this is a start state, and final state we have to indicate using two circles, that is Q8. So this is the method, Thomson construction method. That's a simple method to convert different regular expressions to epsilon NFA. Thank you.